Hello. Welcome to my weird DIY project of my frequency shift keying radio. So basically, the reason I've decided to make this is I don't know. I mean, I'm part of like a radio club. I have my general license, and uh, I guess this was something I wanted to do to like help another project with satellite communications, and I wanted to do it with like the lowest bandwidth. So I decided frequency shift keying was probably the best way to like transmit images. Um, and I'll go in that a little bit, but right now I want to show you some circuits that I designed. Um, right here we have what I call the two oscillators. So basically, we have two oscillators, one right here and one right here, and they'll each get activated um, by a pulse wave. Pulse wave being right here with the voltage offset. This pulse wave will come from an Arduino Uno because that's like what I have. Um, but like that pulse, it goes from 5.5 to 0, um, but with like transistors, transistors, you need a negative voltage to activate the lower, the PNP transistor. So I have a voltage offset. It's going to go to ground. So basically I'll run the program. Okay, so here's the pulse. It's not exactly perfect, but yeah. So here's the pulse wave. Here's the I guess base frequency when there's a zero. We'd like to represent a zero. Here's the other frequency to represent a one. Um, and then if we uh, do the pulse with the wave, we can see how they are activated at different times. And this is kind of the design I did. Uh, I'm sure there's a lot of stuff that I could add to it, like capacitors and stuff, and maybe you know fix some of these resistors so they're not like weird random values. Um, but yeah, that's pretty much all I could think of. I have this built out, but I'll show you that in that other part of this video. We'll go on to another design. Um, let's go with I'll show you the amplifier. So basically, we have an input. I'll go on Reddit. We have an input voltage here, Vn. Um, I estimated that to be like 3.5 volts, but it should be higher. It should be about 5 volts. Um, and then we have a voltage amplifier with two power supplies hooked up to it. These power supplies, they're kind of a weird voltage just because I bought some weird looking what are they called, like LTC power supplies that you have to hook up manually. Uh, and then yeah, so C receiver for voltage supply. So I'll have like a few voltage divider points to supply 14.4 and negative 13.8 to both these op amps. So yeah, we have a voltage amplifier, and then we have a buffer to divide like between the two. I would go with like a transformer, but like that's a lot to work with, and I don't really know how to build a sufficient transformer. Or just I guess I could buy one, but that's kind of dangerous. So buffer, it's pretty simple. I got some op amps that would do like 600 megahertz or whatever. I got like three of them on eBay for like $5. So I think it's worth it just to go with a buffer. And then we have two transistors to allow for a higher ampage. So basically, the wave comes in, and then this will transmit power, or this will transmit power depending on where the wave is. So see right here, this is the wave that's going into the transistors, and then what comes out It's slightly off, but it should be nearly good. It should be enough for basic data like transmission. And I'll probably later on, um, I'll probably make this into a single sideband radio with voice instead of just data transmission. Although that requires like a bandpass filters and stuff, which is the hardest part. Or so I might just like do a double sideband and just not worry about like which side it's on, which is really not good. It's really not good way to use radio, but you know it's a DIY project. So and then we have this potentiometer, pretty beefy potentiometer, 20 watts. I'll put a picture up for it. Um, it's it's gonna go to like the technically ground, but quote unquote ground, but it's really gonna go to my antenna. I'm not really sure how it's gonna play out. LT Spice doesn't really do antennas that well, so I might have to like remove this potentiometer. There might be enough amps, enough watts for there not to be. Well, if we look at the potentiometer, we have about what? How much do we have? We have about 1.6 amps, and that's also at 11.3 volts. So that's what is that like? Basically 18 watts. And I believe the antenna I have for VHF UHF is 20 watts max. So I thought that's perfect. That's the amplifier. That won't be late. That will be later on. And then on the receiver Arduino LT Spice model, I just have like this is really outdated. This is pretty old, but this is like what I want to focus on. This is just my voltage divider. As we could see, like this like the divided voltage. So if we run this, see that what this is 22 volts. This will go to the amp, and then this is like 11 volts, 11.4 volts. This will go to the oscillators. And then I'll later divide on that. Right now, I don't have this exactly in place. Oh, and this is negative voltage. No, actually, yeah, this is negative voltage that I will, yeah, it'll go to the Arduino to lower the pulse voltage. So yeah, so this isn't in place yet. I'll show you what I have in place. So this is basically what I have in place right now for the oscillators. So right here is where one oscillator will be. Right here will be another oscillator, and R2 and R1 are just like their internal resistance to ground. Notice how one is 1.5 and one is 150k kilo ohms. That's because I might have messed up this one. I might have messed up this oscillator, or I could have messed up this oscillator. I'm not really sure. Because I was soldering them. They are very tiny, literally not like 0.5 millimeters long. Like it was incredibly hard to solder. I had to buy like these things to solder to that'll go to like a pinout and stuff, so I could use it on my breadboard. It was annoying. These oscillators are made for like PCBs, which I'm not working with PCBs just yet. Maybe later on if I can figure out all of this stuff. Okay, bear with me here. This is gonna be pretty complicated. Okay, so you have the Arduino Uno. Okay, that'll provide the pulse coming out of this pin, going into here, and we can kind of see. It's really hard to see. We have it going to both these transistors. Or wait, yeah, we have it going both to these transistors, which are also connected to these oscillators. Here, the oscillators. On the other side are the actual parts, and so we can see like they're getting supplied voltage here and here. It's connected to ground here and here, and the So the oscillation will come over here and here, and their complementary will come out of here and here, which is basically like the inverse. So that'll be useful later on when I decide to do a single sideband, because then I will modulate a voice onto this wave, and then I'll add it to this wave using like I guess an op amp. I hope that works, which will remove the carrier wave, which is like necessary for single sideband and stuff. Single sideband, I don't need a bandpass filter. Okay, so these oscillations will then get controlled by this, which one will go through all these resistors into here. Okay, so this is the output, and I will connect this to my Teensy 4 that I have that does 600 megahertz, and hopefully I will be able to read what the frequency is and write ones and zeros based on that. Okay, so next I will show you the code for the Arduino 4 and the Teensy that will go right here. Okay, so this is the code for the Arduino Uno, which differentiates which oscillator we activated at a given time. So here we have what the image data, basically just a set of zeros and ones. I'll have to figure out how to do well, I know how to. I have a program to make a video, make an image turn into binary. But then I'll have to have a way for that Arduino to read the binary. It'd be a lot simpler in Java and Python, because I could just be like, oh, read this, and all that. But you can only have a certain amount of data at a time stored on the Arduino Uno, so I might have to compress the video, or the image. So start the pin mode, it'll be pin 12 or whatever. So for each data, like say 0, it'll write low. If it's 1, it'll write high. That's pretty much it. And I counted the cycles based on. Wait, I think this is a little bit wrong. I think it should be about 57 cycles on the oscillator, and this is important because we kind of need to tune the Teensy 4 to match the transmit rate. And I'm not like a huge expert on all that. Next, I'll show you the receiver the receiver program that will be on the Teensy 4. I always have a. Why are you always? Arduino IDE is not good whatsoever. Let's just say that. Okay, so here we just kind of like define a few things. A lot of this is just for like what is the ARM processor that's on the Teensy 4, which is like pretty nice because it does 600 megahertz clock rate, which is kind of essential for reading data at high speeds, and making the whole thing pretty fast. I mean, if we look at the Arduino Uno, it only does 16 megahertz on this clock rate, so we can only do so much data transmission. Okay, so we have our setup here. We have a bunch of variables. Our setup, we begin a serial write. This will be where we find what frequency it is, just like for testing purposes. Here we define ARM cycles, which is like processor cycles, and then we say there's like 0 ARM cycles. This will help us with like the frequency detection. So basically this attach interrupt thing, it's kind of like it'll detect when there's a high pulse going across it. So if there's an RF wave that is above 0 watts, it'll detect it, and then it'll activate the interrupt function. And here's the interrupt function. It basically says it tracks what the time duration between the start or the last cycle um, which at the start is 0. So there's 0 cycles, um, and then when it detects an interrupt, it'll give you like how long this pulse goes on for, um, and then you can use that pulse time to determine the frequency. So that's the best way to determine frequency, um, especially at this VHF and UHF, about 450 megahertz and a little under. Um, it's easy because the clock on the Arduino Uno is like 16 megahertz, so we have a little bit more time to determine what a wave is and write it down. So it's basically saying, if the counts exceed like the maximum integer, um, it'll like clear it out. Okay, so then we track what the last cycle is, and then it goes on to the loop function. So loop cycles equals like the arm count. So basically, we're tracking what the arm like frequency counter is at, like what its count is at, so we could track like time. And then we'll have like a few delays just so we're not tracking the same frequency over and over again. See if we have like the uh, same um, uh, exact same like time duration of the pulse wave from the Arduino Uno, we can determine like we can put that exact same duration in here, and we can keep on reading the frequencies without worrying about reading something twice, because we know like where we are reading the frequencies, it's not gonna change. Um, so basically, if the frequency is above a certain point, and we can differentiate on that a little later, we have we write it down a 1 in the list, and if it's 0, we write down, if it's above this frequency, and below this frequency, we write a 0. And yeah, well, then we delay it however long we determine. Right now, I'm not sure how many nanoseconds. This will have to do a lot of trial and error. I also don't know if my oscillators will even work right now, because I messed them up while soldering them. That was a whole process. I'm not going to put in a video of the progress of me soldering, because it was a mess. A lot of people who follow this project will know that it took me quite a while to figure out how to make these usable, and I might have messed one up. So yeah, that's basically my code. Can't. It's been a while since I've looked at it. I may have messed up some things. If you have any recommendations on what I should add, either in this code, or in my diagrams, I'll have the at least this code linked in the description, and please feel free to comment on anything you think I should change. Thank you for watching.